Here's Azure guy with another interesting video, and this time it's not about a bits and pieces discussion, but it's more about an implementation, a complete implementation of a Kubernetes multi-tenant architecture. Okay, so what exactly I mean is like when you have an ask from your company to implement all of your applications inside your AKS cluster. So basically these can be a containerized solutions which you want to give out for all of your customers, for all of your internal teams or all of your customers or internal customers in fact on a single cluster. Or they can be use case like like you have applications of different environments and you just want to keep it on a single cluster. Okay, but this is a rare case because each environment with comes up with a different environment, different subnets or vnets configurations which they align to. Okay, so basically this would be a case where you have multiple applications, multiple customers, and you want to onboard this particular multiple customers into a single whole Kubernetes cluster. So I would be talking about more about the Azure Kubernetes service. So the Kubernetes offering is same across whether it's AKS Azure Kubernetes service or whether it's EKS or whether it's on GCP. It's all the same. So the main basics what you need to understand is all the same. But yes, I'll peek into a certain points where it would be a little different from the other particular cloud vendors. Okay, so let's start. Okay, so you have like if you take an example of your complete Kubernetes cluster, what you want to achieve is like you want to host your applications, and you want to make this particular applications available outside world, and maybe sometimes make it available to internal domains as well. Okay, and I have made a brief YAMLs or the scripts which I gonna implement or you know run in order to provision the AKS cluster, in order to provision the namespaces, which is a logical grouping of each particular tenants or applications. Everything in my GitHub repository as a project, and that would really help you because these many months which I've actually put on my efforts in building up this complete implementations, you can actually do it in within a few hours. Okay, so let's speak about the complete architecture, then you will know the actual uh, the importance, or the you will get the gist of where exactly I'm speaking about this particular topic. So the topic is about Azure Kubernetes Service Multi-tenant architecture. So if you take an example, if you have an applications which want to which are hosted inside your Kubernetes cluster, and you want to get it accessed from the outside world, so what you're going to do is like a simple architecture or simple implementation in your enterprise would look like this, where your external application is trying to access f1.domain.com. Basically this domain.com is registered in your public DNS domain name services, like it can be an Azure domain name services, or you can go with any GoDaddy or any other DNS services. Okay, and then when a particular applications would be a request would be coming for this particular app1.domain.com, it would hit your application gateway in case you have one in your organization, and app gateway being very specific to Azure, this is a first interaction where it comes into the Azure network, and then it would redirect to internal load balancer. As you know, like if you run Kubernetes on Azure, which is known as Azure Kubernetes Service, so it would spin up a load balancer. It do not spin an internal load balancer. Okay, so internal load balancer would be spun only if you are spinning inside your cluster something called as Nginx. Okay, so how exactly you're gonna spin your Nginx? It's very easy. You can go to my channel or just type for Helm chart Nginx, and this is a first Nginx Ingress GitHub link which you're gonna get, and it shows how exactly you add a stable repository of Nginx Ingress into your. Basically you can run with Cloud Shell or with your own clients, whatever you're using, and you can install your Helm your Nginx while using Helm. So once you define or create your engines, so basically it would create Ingress controller. First, specifically for creating Ingress controller, there are specific steps. You can Google them about, because you need to create an Ingress controller of engines mapping with your internal load balancer IP. So how you going to get the internal load balancer IP is just go to the portal and get any of the free IP addresses on which, like from your VNet or subnet, which you actually gonna tag with your complete AKS cluster. Okay, take that particular free IP address and assign to your Ingress control creation for engines. So what it would do is, like when you run that particular command for creating Ingress controller, and basically the Ingress controller would be created under the namespace cube system, okay, which is by default provided by Azure, and it is well managed by Azure itself. So when you give the IP of so a free IP from your subnet, then it would go and assign it to assign it to the internal load balancer, and it would spin an internal load balancer for you. Okay, so when this happens, you will have an access for your internal application to come through inside your internal load balancer to your applications. Okay, so this is one particular main step which you need to do when you set up a cluster. After it's a post creation after you setting up the cluster. So how would you create a cluster? We will be I'll be saying it later, pointing to the right script which you need to run to provision your complete cluster on AKS. So that's what, whenever you get request, it will go through, hop around all of this particular thing, and you would ask me a question like, why we are using an app gateway, which is also a reverse proxy sort of mechanism, and then we are also using engines. Okay, so app gateway can be very constant with all of your organization, and you don't want to overload, or you don't have a lot of customization access to do some custom rules or rules definition. Okay, you can't define much rules until unless you have other administration team or network administration team who can help you in doing that. Okay, so that's why we have something called as engines in place, so that you can customize according to your customers need in your particular AKS cluster. Okay, so once you have engines Ingress controller installed inside your particular Kubernetes cluster, which is under particular your Azure managed namespace, then you can say this particular boundary is the complete Azure Kubernetes services. Okay, so obviously your Azure Kubernetes service would be part of a VNet and a subnet, and as of now you can define a subnet and it is fixed for a cluster, but a VNet you can actually expand over the time. And if you go ahead, what I gonna speak is about the request redirect exactly to your pod or application. Okay, so once the request comes your engines, the engines being a reverse proxy mechanism which implements a reverse proxy mechanism, it actually knows the services which are exactly running inside the pod or inside your particular namespace. So as a said, namespace are sort of logical grouping where you will keep your customers isolated from other particular customers, or you can keep your applications isolated from other particular applications like that. Okay, but when you create the AKS cluster, you will be either choosing a Kubernetes network plugin, or you will be using the Azure CLI network plugin. So the difference between the Azure CLI and Kubernetes are like the Azure CLI actually takes up the static IP addresses, or the IP addresses which would be part of your subnet, and it would provision your pods on that particular IPs. But with Kubernetes, it would sort of roll out view the virtual nodes or virtual IPs concept, and it would actually gives more number of IPs with the VNet or the subnet which you are providing. Okay, so as of now, if I remember correctly, Kubernetes can host 3 times or 4 times more IPs, or you can host 4 times more pods than you can provision with Azure CLI. So be wise, take decision correctly before you're choosing an Azure CLI or Kubernetes, before spinning up your cluster, either using a CLI or PowerShell or any other mechanisms or REST API in fact. So once the request gets redirected to your particular namespace, So then it would know, like, which particular pod, or it need to, or application it need to land, which particular port it needs to land. So where exactly we define that particular criteria is in this particular location called as Ingress. Okay, so we would define Ingress. It can be, as in multi-tenant architecture, it's always advisable to define your ingresses in your namespaces, so that even if you change your ingress, a particular ingress, it won't actually impact your other particular namespaces or your customers or your applications. Okay, so we will be having an ingress which is specific to namespace, and the ingress file would be very specific. It would have a detail about the service, the port number where it is hosted, and it do not reveal about the IP addresses, because the IP addresses may change. Because think that scenario, like if this particular pod which is running, and it has a IP address which you made an entry to Ingress, and it had died, okay, or it expired. So in that case, you actually lose a contact to this particular pod or IP. You need to make an re-entry. So for that only, Kubernetes provides something called as service tagging. Okay, you can use your service name and tag it to your ingress and your port number, and then you can, and actually you can also make an host entry. Like if you have something called as app1.domain.com, you can make an entry of that particular host in your ingress, and then you can give an access to, or an entry of your service and your port number. Then whenever your user wants to connect to app1.domain.com, it will come all the way here and here and here. It would cross all the hops, and ingress being sort of map store, and when you define an ingress, it would actually make an entry of your the key value stores, or the mapping of services, and the host in your Nginx controller in the master table. Okay, so that is one thing, like how exactly. So once you make the entry of this particular services and host in the Nginx via the ingress, so now it's Nginx ingress controller responsibility to reverse proxy, and then continuously making a health probe on these particular services, and know whether the services are running fine or not. Because that entry need to be there, as very similar to traffic manager, where or load balancer traffic manager, where actually it would remember the state of each of the services, whether they're active or dead. Okay, accordingly it can disable in the master table, and whenever an application request comes, it would not redirect, rather it would redirect to another node where exactly that particular app is running. Because when a pod dies, the pod would be recreated if you define in your deployment.yaml by the Kubernetes. Because the Kubernetes being your being an orchestrator mechanism, it always makes sure that at least a one or two replica, whatever you define in your replica set, is running across your nodes and across your cluster. Okay, and then that's one example where how exactly your request gonna read out. Okay, and if you go a little deeper on the namespace level, you can actually apply something called as resource quota. So we will describe what exactly is resource quota, and you can define limit. So resource quota in simple, what I would define is like how much this particular namespace, or the users or applications or pods can actually consume the quota or the quota out of the complete quota of the cluster. So in fact, the quota would be depicted in terms of CPU usage and in terms of memory. So CPU usage would be quantified in terms of cores, number of cores, and in case of virtual machines, or in case when you're not running on a physical hardware, or when you're running on virtual machines, it would be calculated more in virtual CPUs, so which would be calculated in cores. So we will define CPUs in terms of core, and the memory in terms of gigabytes, and you will come to know, like when I'll define more about the YAMLs which I will be using for this. And you have pod security policies, but I'll be placing the YAML in the future, and I have applied also something called network security policies. So network security policies would define that, like which particular namespaces or which particular applications in another namespace can access your applications or your particular pod or your particular service. Okay, so that is very important to in order to maintain isolation in your Kubernetes cluster when you're sharing across multiple tenants. Okay, so that is one particular implementation which I'll be talking about, and your particular pods can run your own particular or spin your own persistent volumes. Okay, and there can be cases like where your applications will be talking to external Redis cache or SQL Azure, or in fact, any of the relational databases running on an infrastructure as a service, whether it's AWS, GCP, or Azure. And there may be possibility like your particular applications can also be talking to the service endpoints in your on-premise. In that cases, you need to take care of IP whitelisting, or what I can say is firewall firewall change request FCR, which you can provide to your particular network administrators, so that they can whitelist your particular IPs in there. But there's still a question whether you gonna like whitelist your subnet, or you VNet, complete VNet with your particular applications, or you're gonna whitelist a specific IP with your particular on-premise FCRs. There can be a scenario like your applications may be talking to a non-relational databases like DynamoDB or Azure Storage, or maybe talking to your service bus. And then, so this is one perspective where your requests are coming and they are interacting with various applications, and applications are integrated or interacting with the secondary databases, maybe with the primary databases or disks persisting in the persistent volumes, and how exactly the quotas and everything would be implemented. Network policies are implemented on top. Pod security policies talk about more about who can access the pod and something like that, and the resource quotas would talk more about how much a particular, because what happens is when you share uh, resources among different customers, you need to, as a platform managing team, it's your responsibility to equally share the resources among all of the tenants. Okay, so in case you have a prior a prime tenant, then you would like to spin up another cluster and give him a prime cluster for him, because what happens they can be a scenario like you have a customer who want to spin a load testing emulators, or in fact they want to spin a lot of emulators, mobile emulators. Okay, take an example like a mobile emulators which would implicit like they want to run emulators which would occupy a Android emulator, which would be a example of a Android device sort of running. Obviously those devices will have a specific IPs, so that you can carry out your app testing in those particular devices. Think that you want to test your app for a failure of for across 1 lakh devices. So in that cases you can't actually go ahead and give those number of 1 lakh IPs on your Azure CLI. Okay, so in that cases you may be spinning up multiple clusters, or you would be using Kubernetes with 2 or 3 clusters, and then you would be provisioning that particular implementation for the customers separately, not on a shared cluster in these sort of cases. Okay, so when we have shared clusters, you would also mean that the customers use their own fair usage of resources which would be have been provided to them in the starting when you onboard. So we have a YAML where you can mention that particular fair usage or the threshold a customer can use. That's where we use something called a concept of resource quotas. Okay, so if you go apart from this, if you cover this particular scenario, we have something called as namespace user, namespace admin, cluster admin rules, which we define as part of Kubernetes scope, and we integrate the complete cluster with Azure Active Directory. Okay, because we just want to Azure Active Directory in this case, or you can use IAM with Amazon AWS services, or with GCP you can use IAM, where your identity is stored somewhere in Azure Active Directory or in IAM. And basically when I say about your identity is like your user identity, like if you have something called as xyz username at domain.com, your domain can be your company.com, and the tenant is something dot domain.com, your company.com, and in that case it's like your identity is stored in Azure Active Directory and you don't want to spin, or you don't want to create a new user identity, right? Like rather you want to use the IAM or Azure Active Directory for authenticating and authorizing your particular services, or your particular services or access to your particular Kubernetes. Basically, when this particular users and anonymous users comes and try to access your cluster with a kubectl command, or he's tried to log in with AKS credentials, then your Kubernetes API server is quite intelligent, and since it is enabled with RBAC, and so it will redirect your call directly to AD, and you will be redirected to AD, and you need to authenticate the present your credentials, and then authenticate with AD, and then you will be redirected to back to the Kubernetes API server to execute your kubelet commands. So you can see these dotted small gray lines, and they are about the kubelet commands which you can execute on the namespaces. Okay, so for your information, like we restrict each of the users, so namespace admin can access any of the namespaces, but the namespaces user or namespaces admin may be restricted to a specific namespace. Okay, he may be owning a single namespace, or he may be owning multiple namespaces, depending upon the use cases, depending upon the applications or customers use case scenarios. Okay, so what happens is like customers can kubelet into any of their particular namespaces, and they can spin their services, and but all of the services, whatever they need to spin, they need to adhere to the concept of the resource quota and threshold. They can't cross. They can spin number of pods, a number of infinite number of pods and containers, until unless they are under the fair usage, which means that each pod you would be defining or splitting your resources, your usages, according to the number of pods you are actually running. Okay, so there is no limitation, or there won't be any limitation of pods, but yes, you can also limit the users for the spinning of the pod, but exactly you're actually putting up limitations on the resource usage itself, so there's no need of pointing or limiting the users from creation of pods. Okay, so that is one case. So once we have everything, so you would also once you have namespace running, your applications are onboarded. Either the applications would be spun using Azure DevOps, or customers can run their own YAML, or they can put their particular access on Azure Container Registry, and then put their particular or pull the image from the from the Azure Container Registry. Sorry, I didn't mention about the Azure Container Registry, but the thing that you have an image on Azure Container Registry, and then they can push their application into the namespace. Yes, you can see a lot of these services, Azure Key Vault and Azure Kubernetes Service, the Azure Container Registry. So these are sort of the external resources on whom your particular container need to have access, right? So I would be mentioning I'll give out the article how exactly you set up AD or RBAC controlled AKS cluster, where you actually would be creating two service principles, like one is server service principle and another is client service principle. Okay, so the server service principle talks more about how exactly you will be you'll be creating an AD app in Azure Active Directory, and in IAM for the AWS and GCP that would be a little different, and for Azure Active Directory I'll be mentioning how exactly you would do via the link, and you will be creating a server app. Okay, so the server app which would you create, it would actually help you in authenticating with this particular secondary services, like it can be Azure Key Vault. Your cluster want to talk with Azure Key Vault, your cluster maybe want to talk to API management or any other external Azure services. You actually need a server principal. If you make this server principal as if you give the server principal access to Azure Key Vault in the IAM services in Azure, or to the API management, or to any of the services, then when you give the service principal and access, then the cluster as a whole will have an access to that particular services. So that is one integrations which you can do. The second is the client service principle, which you will be defining. So the client service principle, what it does is like a lot of kubelet commands you can see, like you can kubectl commands you would be running. So those also need to be authenticated time to time. So the client service principle is responsible to authenticate those particular requests, and that's how the complete security of your particular AKS cluster is taken care. And on top, you can also secure your Kubernetes API server calls. So the calls, think that if a random user is coming and making a call to the Kubernetes API server, right? So think that that particular user entry is not stored in AAD, but he's trying to make a DDoS attack on your Kubernetes API server. How exactly you going to save it? So the simple method is like you can whitelist your IPs using something called as authorized API server IPs. You mentioned your IP ranges, and then that would help you in whitelisting the IPs. Like you can just allow IPs from your on-premise VNet, or your own domain network, your own company network, or your own DC network, or your data center network. And also you would be whitelisting the Azure DevOps server. And if you're specific, like you have Azure services which are going to interact with your cluster, which are specific to region like West Europe or anything region, you can actually go and get those particular IP range, and you can mention that particular IP range in before creating your cluster, and even you can modify after creating a cluster. Okay, so that is one way of securing your Kubernetes API server from DDoS or any other attacks from outside world. And yes, we've talked about lots about setting the cluster, everything, but what about the monitoring? We didn't talk about monitoring, right? So one of the key or the default features which are given by Azure are like you can use Azure Monitor to know the health, to know the containers which are running, pods which are running, and it's a very seamless experience, like where you have each and every details without logging into a cluster. You have all the information and errors which are happening on your cluster for over a retention period of 90 days. You can see all the logs, and in the issue monitor, which will show whether the cluster is healthy or not in direct way. Or you can actually go and check in log analytics. You can write your own Kusto query to beautifully template any particular charts, and obviously you can use log analytics to dump your logs from your particular cluster to back up this particular logs for more retention. Like if you want to save your logs for 1 or 2 years, you can actually do you can copy the log analytics log itself and to your have a job which can do for you and store in storage, so that, and you can output onto your any reporting tools, and which would have a complete life cycle of what are the number of issues which would have come to your cluster. Everything you can debug. This is very important in cases where what happens, like if you have a running prod, if you're running this particular workload in prod, and if you have any issues with the pod, okay, and the pod would have got killed due to some issues, like whether it would have it's not able to make a call to the dependent service, and it's getting 500 errors or any other particular internal issues. You can't actually debug until unless you have the logs in it, right? So like dynamically or at runtime, you can't go and get the logs of a killed pod. But what you can do is like these logs are stored in your log analytics, and if you can save this log analytics logs, then you can actually debug what exactly happened happened with your pod, and why did it die at the first instance. Because the Kubernetes being an orchestrator, it would actually spin another pod without caring about whether why exactly that pod had got killed. Okay, for that cases you need longer auditability and logging for sure for AKS cluster which are running on prod. And on top of that, you can actually have something called KubeCost. So KubeCost, okay, so I'll be defining Prometheus and Grafana and KubeCost, what exactly I've used. These are required because when you are setting up a multi-tenant architecture, you need to log in, or you need to know more details about your namespaces. But that by default is not as of now. By 2020 May, you are not able to get those particular logs using Azure Monitor log analytics. full-fledged, what you can do is like you can have Prometheus or Grafana, Prometheus and Kubecost to do it. Okay, so Kubecost would give you more of your namespace cost, how much a particular namespace is utilizing, what is the resources they have utilized, what is the quota they have, whether they have crossed or touched the threshold or not, whether they are reaching the threshold nearby, whether they are consuming the resources and they are going to meet up the threshold. Those particular parameters are which are very required when managing up your AKS cluster in the prod. Okay, and then you would also want to crawl this particular endpoints, whatever services have been hosted, whatever the pods have been hosted, irrespective of namespaces, whether these namespaces are with the kube system namespaces. All of this particular data can be, or the requests which are coming from the outside world, all of this particular data can be crawled using Prometheus. So Prometheus cross this particular data and saves in their own persistent volumes. Like if you're running your Prometheus as a container, then it would spin up a pod, a few of the pods and services, and then it would have a persistent volume where it will you can actually persist data of 90 days in the persistent volumes and then get it backed up for a longer period. Okay, so but as of now, the Prometheus, when it runs, it would store your values or the metrics into your persistent volumes. Okay, so once the metrics are stored in the persistent volume, Prometheus also does a good credibility, is like exposing those metrics so that other resources, other services can use it. So it would be very easy once the Prometheus exports your namespace metrics or other particular internal metrics to the outside world over secure service endpoints, so the IP addresses, you actually can consume in Grafana. Grafana also can be spun over the pod or container, and you can give the service endpoint to Grafana, and the Grafana would try to read your metrics API, which is export from Prometheus, and put into a beautiful dashboard. The similar way Kubecost also works, it would consume the Prometheus endpoints, and then it would give out a lot of the gist or a beautiful representation of your particular usage and everything which is running in your cluster. So this is so you can integrate, once you have Prometheus crawling your particular data, you can integrate with Kibana or any other monitoring system, even with the Datadog. So how exactly you want to spin up a Prometheus in Grafana? It's like simple Helm charts which you can use and you can install. And I'll be putting those particular charts, basically efficient charts, where you can just run 3 command lines and then 3 CLIs and you're good to go. And so this is a complete implementations which I've talked about, and in the part 2 we'll be talking about more about the YAML files which I've talked during this particular architecture.